Today we're talking about traditionally what's called one-dimensional kinematics is a fancy word. Linear motion is the easier way to define it. Notice what's in the word linear. The word what? Line, okay? So one-dimensional kinematics is a study of things that move in a straight line. Sprinters running, sports cars taking off from the starting line. This is an awesome picture here. We're going to look at this later on. A very famous professor at MIT, he's actually the guy who invented the strobe light, took this photo. It's a rifle shooting the king of diamonds in half. And this is one of the first photos where we prove that bullets can go faster than the speed of sound because it forms a supersonic shock wave, and you can see it carving through the card there. Really cool, right? And in order to understand how to take a cool picture like that, you really need to understand how things move. And today what we want to do is introduce the basic ideas of linear motion. What do you suppose the word kinematics means? It's a fancy word. Kine is from the Greek, and I want to take a guess what kinematics means. Kine is the Greek root for motion, okay? That's all. So that's just kind of a little bit of vocabulary there. So if you, again, if you want to go into sports medicine or coaching or whatever, you'll usually be a kinesiology major, etc. for sports medicine, okay? So first big idea is we need to find the idea that motion is relative. Like, what does that mean? All that means is you have to define your frame of reference. And basically what we're trying to pick is what's your origin? Where do your x and y axes lie? Okay? So a simple example is the surface of the Earth versus the center of the Earth. And I know this sounds kind of weird, but let's just pick something simple here. So here we got someone's comp book here. Very exciting. And I'm just going to put it right here on the lab table. Very exciting. Are you excited? That's okay. Quick question. Is that lab notebook, is it moving? I'm just going to stand it up right here. Is it moving? Woo! Very exciting. Yeah, if you ask most people, they'd be like, what's wrong with you? Like, of course it's not moving. It's just sitting there. Like, what are you smoking? Right? It's just sitting there. Are you crazy? So that's correct. That relative to you and me, its motion is like 0. It's going 0 miles per hour. If we want to be all metric, it's 0 meters per second. Okay? Now, suppose we had nothing better to do but to sit here all period and stare at that notebook. Okay? And in fact, not only do that all period, we stay here all day. Okay, we just stay here all day, and then we stay here all night, and then we stay here till tomorrow morning at whatever, 8, 11, whatever, okay? Because we have nothing better to do. So relative to you and me, is that notebook going to move? Probably not, okay? Unless you're like, ooh, that's bad, okay? Just lay off, come talk to me, I'll get you some professional help, okay? There you go, just kidding, just trying to keep you awake. Was that inappropriate? Maybe. Oh, I'm recording. Anyway, there you go. Just trying to keep you guys awake. But here's what happens, okay? What happens once every 24 hours? Anybody know? Something weird happens. What happens? Sure. That's correct. That once every 24 hours, that notebook will go around the center of the Earth. You see that? Okay? So you know what's crazy? In order to go around the Earth in 24 hours, what do you think? You have to go fast or like crazy fast? Anybody ever fly, like, overseas, really far away? Actually, you're flying really far away, yeah? Where are you going to fly again? What's that fancy country called? Oh, yes, Switzerland. And how long is your flight? 12 hours. That's ridiculous. And that's not even all the way around the world, right? Okay, anyone else fly far away? Yes?
I've been from Australia
Australia to Hawaii. That's ridiculous. How many hours?
It was like, maybe like
15 hours. And that's not even around the world. Yes?
I went to Pakistan.
Pakistan.
Yeah.
Wow, that's literally like halfway around the world. How many hours?
It was
It's like
5 to Turkey and then like 12.
5 to
12 to Turkey and then 5 to Pakistan.
12
So,
to
like,
Turkey, 5 to Pakistan. So like 17 hours. Okay? Yeah, you know what? Little bonus if you want to figure it out. Okay? Just include it in your notes, right? Bonus! There you go. Okay? When I check it over there. Actually figure out how fast that notebook is going around the center of the Earth there. Okay? And what's crazy is, actually you can figure out, how do you figure out the distance around a circle? It's like a little bit of geometry, right? Distance around a circle, what's that called? Starts with a C, something, a reference, circumference. There we go. You have to get 2 pi r, the radius of the Earth. You can look that up online. And then what's the time? The time is just, how many hours in a day? Man, this is too early. How many hours in a day? 24, right? Okay, so you get miles per hour. It's over 800 miles. You're going to see that, okay? So what's insane is that notebook is like going faster than the speed of... Let's say it otherwise, the motion is always relative to something. And normally, since we live on, what, the center of the Earth? Where do we live? On the what? Surface of the Earth. We're assuming that's our frame of reference, okay? Normally we don't think so abstract, like the Earth is going around the sun, we're going around the center of the Earth, the solar system's going around the Milky Way galaxy. We just assume that frame of reference, okay? So now as a little quick check, this is a short little video clip. You guys ever see Sesame Street when you're a kid? One of these is not alike, okay? So this one you have to figure out, is a train moving? Is a lady moving? Ooh, is a boat moving? Is a man moving? Okay, here we go. Next big idea is speed. You already know what speed is. What's speed? You have to know this so you don't get a ticket, especially coming to school in the morning. Watch out, it's the end of the month, right? Or is it the beginning of the month? Whatever, right? There you go. Some of you guys already have tickets on your record, I can tell. That's okay. What's speed? Speed is equal to what? Real simple. It's like 6th grade math. Speed is distance over time. There you go. Okay? Speed is just how much distance you cover in an interval of time. It's the rate of change of position with respect to time. It's a fancy word. Equation, let's just use S for what? Everybody. Speed, right? D for distance, T for time. Technically, you can pick any symbols you want. You could say chickens equals fish over cows. That just gets confusing. Let's just try to keep it consistent, okay? Speed equals distance over time. Units. This here United States of America, we ain't use no metric system. What do we use to measure speed? We use miles per hour. Watch out, right? 55th Street, speed limit is, I see people pull over all the time, 35, there we go. And then what's that little street on the side? I think it's only like, Madison, thank you. I think it's only 30 there. So be real careful, okay? Anyway, the rest of the world does not use miles per hour, right? They use what? What's the metric unit there? Kilometers per hour, right? So if you go to Canada, or you travel, you're in Switzerland, Pakistan, wherever, right? Any other country in the world except us and I think a little tiny country in Africa, watch out. Because usually it'll say speed limit 88. And you'll be like, woo! Like, I love these Canadians. And you're going 88 miles per hour, you're going to get a ticket, okay? Because 88 miles per hour is closer to like 130 kilometers per hour. But really, 88 kilometers per hour is our 55 miles per hour. So you just got to be careful, okay? And as the world becomes more metric, you'll see like in the Olympics, in swim meets, whatever, okay? Track and field, it's all going to be in the metric units of meters per second. The next tricky idea we want to distinguish is what's called average versus instantaneous speed, okay? Average is pretty easy, except it's easy to mess up when you do like math problems. You're tending to just do like a math average. How do you find the average of 3 numbers? It's real easy, right? You just add up the 3 numbers and divide by what? By 3, right? Okay? In physics, you can't do that. It doesn't work. Because in physics, it's your real average speed. So if you drive 50 miles an hour, and then 75 miles an hour, and then 60 miles an hour, you can't just add up the 3 speeds and divide by 3. Because in real life, you might be driving 3 different speeds, but for different amounts of time. Okay? Like when you're on a road trip. So to get your average speed, it's actually pretty easy. You just take your total distance over the total time. So what's weird is if you go on a road trip, your average speed might only be like 25 miles an hour, even though on the highway you can drive like 60 miles an hour, right? Why is that? Why is it in real life? Anyone ever been like on a family road trip? Anyone go this summer? Last spring, we tried to drive to Minnesota, to Minneapolis. It should only take like 7 hours. It took us like 10. It's like, ah. And anyone want to take a guess? Why does it take a long time when you do a road trip with your family, or if you got young kids or whatever? I have to pee. I'm hungry. Ah. Right? So then you're pulling over at a rest stop. So then your average speed goes to 0 for like half an hour until you get in the car again. And then I try to make up for time. I go like 75, maybe 80. Oh, Minnesota, slow down, right? But then our average speed is like 35 miles an hour. It takes us like 10 hours to get there. Like, okay? So you just take your total distance over total time. How do you get the total distance your car is driven? Anyone know? Little trick, right? There's this thing in the middle of your speedometer. You ever see this before? Down here? What's this thing called? Anyone know? It's your odometer. Just kidding, okay? Yeah, your odometer. It actually just measures the total mileage your car's traveled. So if you subtract the 2 numbers there, you'll get your distance you traveled divided by the time. You can get your average speed, okay? Now, a cool example of all this physics stuff is a lot of you guys have this little fancy thing in your car. It tells you like where you are, where you're going, where you need to turn. It's called a what? It's called a GPS navigation system, exactly, right? And what the GPS system uses is a system of satellites to calculate your position. And then they program in these equations right here to figure out not where your car is, how fast your car changes where it is, how fast it changes how fast where it is. That's acceleration, tricky one, okay? And then it can compute average versus instantaneous speed by using these equations. Your instantaneous speed, what do you suppose that is? That's your speed at any what? What's in the word instantaneous? Instant, okay? And what your car does is it takes a short interval of time to see how far your car went. So usually it's connected to like your tires spinning, okay? So if the car manufacturer knows the circumference of your tires, then they can actually figure out then based on one rotation the distance you'll cover, and based on that amount of time they can give you your speed at any instant there. That's the one you have to care about when you're driving around Hinsdale coming to school towards the end of the month. But officer, my average speed was only 15 miles an hour, even though I was just going 47 because I'm running late to school, right? So you got to be careful there. Got it? So, simple example of looking at figuring out your speed there, okay? So let's say you decide to do a road trip, go visit U of I, okay, down in Champaign-Urbana. It's a good school to visit just to kind of get your college applications going and all that. Anyone ever been down to Champaign-Urbana? Okay, it's a very exciting ride. Let me describe it to you. As you drive down I-57, okay, what you see is corn. Then you see more corn. Then you see soybeans. Then you see corn and cow. Corn. Okay, yeah, not that exciting. Let's say you drive 150 miles in 3 hours. So what's your average speed? This is easy, right? You just do what? 150 over 3 would be 50 miles per hour. That's it, right? But are you actually driving 50 miles per hour the whole time? No, you're not, right? Because in real life, there's annoying things like what? Like stoplights, right? Like traffic. What's with that? Oh, okay. Might see state trooper, especially on I-57. So be careful, okay? So what's weird is your instantaneous speed changes all the time. It might be 0. It might be 35 miles per hour. It might go up to 75 when you're passing a truck. Actually, state legal. 65, right? But your average speed is just your total distance over total time. Here's another example that's a little bit more concrete. Let's say you're on a bicycle, and for the first hour, you ride 5 miles per hour, so you go 5 miles. For the next 3 hours, okay, you put on a little bit of speed, but actually a little bit tired, so you actually only go 4 miles per hour. My bad. For 3 hours, you go 12 miles. And then towards the end, you just sprint for it. You go 7 miles per hour. Wow. For 2 hours, you go 14 miles. Okay? So how do you find your average speed for the bike ride? True or false? You simply add up 5 miles per hour plus 4 miles per hour plus 7 miles per hour, and you divide by 3. True or false? False. Thank you. Okay? That's not true. Your average speed for the bike ride is not simply the sum of the 3 speeds divided by 3. Why? I thought average just means add up 3 thingies and divide by 3. Why doesn't that work? Can you see here? Notice we only went 5 miles per hour for an hour. For the bulk of the ride, for 3 hours, we were going at a slower speed, and then only for the last 2 hours we sprinted, okay? So this could be like a really complicated problem, like you have to do a time-weighted average, blah, 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 okay? Too complicated. Make it easy. The definition of speed is distance over what? Time, right? So all you got to do is add up all the distances, 5 plus 12 plus 14, 17, 14, 31 miles, divided by the total time, which is 1 plus 3 is, 1 plus 3 plus 2. Help me out here. 6 hours. There you go, right? So if we did 31 miles over 6 hours, we could figure it out. That's okay. Okay, it's not about the actual number, it's the idea there. Okay? Okay, moving on. Let's talk about velocity. Okay? Velocity is like speed on steroids. Actually, that sounded bad. Speed with direction is a technical definition. Okay? So velocity is a better way to describe something moving. It not only matters how fast you're going, but which way. Okay? So there's a big difference if you're going forwards versus backwards, to the east versus west, north versus south. Anyone have friends who are like navigationally challenged? I'm talking about they can't even give directions to their own home. We knew a couple that was like that. Like when they were in a car, it was just bad. Like, oh boy. Like, yee. Okay? But anyhow, speed is a scalar. It doesn't have a direction. Velocity is what we call a vector. It's a fancy word for anything that has not only a size, but also direction. So the units are the same, miles per hour, kilometers per hour, meters per second, but what's different is we have to add on direction. For example, when you drive to school, let's say you're coming down 55th Street towards the city, you're going east. What's the speed limit on 55th Street? 35 miles per hour, okay? So you're going 35 miles per hour east. Suddenly, in a fit of insanity, you shift your car into reverse. Is that bad? Probably. You'll probably cause an accident. You start going 35 miles per hour, backwards, okay? Are you going to get a ticket? Are you going to get a ticket? What do you think? I think so. I think a Hinsdale cop's going to pull you over and write you a ticket for reckless driving. But you can say, but officer, I wasn't speeding. I was only going 35 miles per hour. which technically is true, but what's wrong is your velocity. You see that? Okay? Don't do that, by the way. That would be very bad. And the equation looks complicated. It's not that bad. The symbol we're going to pick for velocity is the letter what? V, okay? Now, instead of distance, we're going to use this fancy notation. See this little triangle thingy? Anyone know what letter that is? It is a Greek letter, delta. Power to the Greek people. Woo, there we go, okay? In science, we use the symbol delta to denote change, okay? And the problem is we actually run out of 26 letters in the alphabet, 52 letters altogether. We have more than 52 ideas, so we got to go to the Greek, okay? I remember in college once, I was doing my physics homework in speech class. Shh, don't tell me there. And a girl leaned over, she's like, wow, is that Chinese? And I'm like, actually, it's more Greek than anything. So anyway, that's the Greek letter delta, means changing, okay? You're changing your x, your position. It's called your displacement. So your x final minus x initial will give you your displacement. Over time, your rate of change of position over time is your velocity. Some of you guys are taking calculus or pre-calc. Technically, velocity is the first derivative, fancy word, okay, of your rate of change of position with respect to time, dx dt. If that sounds scary, don't worry about it. You're actually going to do a little like baby calculus and feel all fancy there, okay? So velocity is speed with direction. And to show you guys this, I got this cool little toy.